More than 50 years after the first moon race, a new one is taking shape. The United States may have been the first to set foot on the moon, but this time it's looking more and more likely that China could get there first. And based on everything we've seen so far, here's how they might do it. China is getting ready to take another major step toward the moon, gearing up for what will be its most ambitious robotic lunar mission yet. And this time, a number of international partners are coming along for the ride. The Chang'e 7 mission, officially approved in September 2022, is scheduled to head to the moon in 2026. The spacecraft, weighing about 8,200 kilograms, represents the next stage in China's steadily evolving lunar program. Earlier Chang'e missions focused on single landers or sample return hardware, but Chang'e 7 drops the sample return components in favor of carrying a larger suite of instruments meant for scientific study and exploration. Like the country's previous 2 lunar missions, Chang'e 7 will launch on a Long March 5 rocket from Wenchang's coastal spaceport, with teams currently working toward a liftoff in August 2026. A few days after launch, the spacecraft will slip into an orbit that passes over both lunar poles, allowing it to scout potential landing zones near the moon's south pole, an area of huge scientific interest because of its suspected reserves of water ice. According to details shared at the United Nations Committee on the Peaceful Uses of Outer Space, the preferred landing site is a sunlit ridge near Shackleton Crater at 123.4 degrees east, 88.88 degrees south, with several nearby alternatives. If lighting or surface conditions aren't ideal, exactly when Chang'e 7 touches down will depend on how sunlight falls across these sites. Engineers expect to spend up to 2 months studying lighting patterns and surface features to pick the safest moment. Once the spacecraft gets close to the surface, its landing software, an upgraded version of the system used on Chang'e 3, 4, 5, and 6, will help it dodge hazards and shift to safer ground if needed. After landing, more than a dozen scientific instruments will begin examining the terrain, the environment, and the moon's interior and surface composition. The overall science goals are broad, but centered on understanding the moon's south pole air environment, searching for water ice, studying the moon's structure and magnetic and thermal behavior, and even observing Earth's magnetotail and plasmasphere from the lunar surface. To tackle all of this, the mission carries instruments across several components: an orbiter, a lander, a rover, and a small hopper designed to make short trips into permanently shadowed craters. The hopper will carry a single tool, the Lunar Soil Water Molecule Analyzer, to directly probe icy soils that never see sunlight. In a notable twist, Chang'e 7 will also carry a U.S. contribution thanks to a partnership between the International Lunar Observatory Association and the University of Hong Kong's Laboratory for Space Research. A wide-field optical telescope will fly on the lander. Its job is to capture views of the Milky Way and the galactic center from the moon's surface, a vantage point astronomers rarely get to use. Altogether, Chang'e 7 marks a major milestone in China's lunar exploration plans, bringing advanced technology, international cooperation, and an ambitious scientific agenda to one of the most intriguing places on the moon. Chang'e 7 is just one part of China's broader plan for exploring the moon. On October 30, 2025, a spokesperson for China's crewed space program said the country is still on track to send astronauts to the lunar surface by 2030. So, how exactly does China plan to get there? China's modern lunar program began in 2004 with 3 clear goals: to orbit the moon, to land on it, and to bring samples back to Earth. All of these goals were achieved between 2007 and 2020 through 5 Chang'e missions. Among them, Chang'e 3 marked China's first successful landing on the moon. Chang'e 4 became the first mission in history to land on the moon's far side, and Chang'e 5 brought lunar samples home. Carrying out a human mission to the moon is a huge effort. It demands careful planning, advanced technology, a lot of funding, and a large team of skilled engineers. Over the years, China has steadily built up its human spaceflight experience, starting with its first crewed mission, then sending 2 astronauts, and eventually flying 3 astronauts on a mission that included the country's first spacewalk. To take the next step and send people to the moon, China needs a very powerful rocket to carry a spacecraft and its crew into lunar orbit, along with a lander that can touch down on the moon and lift off again. Right now, China's strongest rocket is the Long March 5, which can send around 8 to 9 tons toward the moon. It's similar in power to Europe's Ariane rockets and America's Atlas V and Vulcan vehicles. However, rockets of this size simply can't lift enough weight for a human landing mission because they fall short of the heavy load needed for lunar travel. To solve that problem, China is developing a much larger rocket called the Long March 10. This new launcher is being built by the China Academy of Launch Vehicle Technology, part of the country's main aerospace corporation. Early information suggests the Long March 10 will be able to send about 27 tons to lunar orbit, putting it in the same class as NASA's Space Launch System. It is designed with the same diameter and many of the same engines as the Long March 5, which should speed up development because engineers can rely on technologies that are already proven. The new rocket could be ready as early as 2027. For a crewed moon landing, China would need to launch 2 of these rockets, one carrying the astronauts and the other carrying the lunar lander. China's launch vehicles already have a strong record. According to the state-run newspaper China Daily, Long March rockets have a success rate of about 97%, slightly below SpaceX's Falcon 9, which is at about 99.46%. Thanks to this reliability, China has been able to set and meet realistic timelines for its major space goals. In August of this year, the country also completed a ground test of the newest version of the Long March 10, another step toward its first human mission to the moon. For China's planned moon landing, astronauts will travel in the next-generation Chang'e crew capsule. This new spacecraft will replace the long-running Chang'e vehicles that have carried all of China's crewed missions so far. Chang'e is made up of 2 main parts, a crew module and a service module. The crew module is where the astronauts live and work, while the service module provides the power, propulsion, and life support systems needed to keep the spacecraft running. Because of this modular setup, Chang'e can be adapted for different types of missions. Officials expect to build 2 early versions of Chang'e. One will be used in Earth orbit to carry astronauts to and from the Tiangong space station. The other will be a deep space version designed specifically for lunar flights. The crew module will be able to hold up to 6 astronauts, double the capacity of Chang'e. The first uncrewed test flight of Chang'e is planned for next year. For the landing itself, Chang'e will pair with a separate lunar lander called Lanyue. The name comes from a poem written by Mao Zedong and means embracing the moon. Lanyue is made of 2 parts, a landing stage and a propulsion stage. The landing stage is where the astronauts will stay during the descent. The propulsion stage carries fuel for the landing and detaches shortly before touchdown. Altogether, Lanyue will weigh nearly 26 tons and will carry 2 astronauts down to the lunar surface. China has been testing parts of the lander since 2024. A robotic prototype is set for trials in 2027 and 2028. After that, an uncrewed mission using both Chang'e and Lanyue is planned for 2028 or 2029, leading up to the full crewed landing attempt in 2030. In 2024, China revealed the new spacesuits that its astronauts will wear on the moon. These red and white suits are built to handle the moon's harsh environment, including extreme temperatures, radiation, and fine dust. At the same time, they're designed to let astronauts move comfortably so they can carry out tasks on the surface. The suits include built-in cameras for both long and short-range views, an operations panel on the front, and a helmet visor that reduces glare from the sun. The announcement caught attention outside China as well. Elon Musk shared a video from Chinese state television on the platform X, adding his own commentary. Chinese state media celebrated the new suit as an important milestone in the country's push toward a crewed moon landing, pointing out that lunar suits must be specially designed and are very different from the ones used for spacewalks at China's Tiangong space station. Musk also used the moment to criticize the situation in the United States, writing that the Federal Aviation Administration was smothering the national space program in Kafkaesque paperwork. His comment suggested that he sees China moving quickly in its space ambitions while the US faces regulatory delays. In the years ahead, China plans 3 more Chang'e missions before the decade ends. These missions are meant to prepare for the next phase of lunar exploration, building a research station near the moon's south pole. This future base is officially called the International Lunar Research Station. It started as a joint project between China and Russia and was designed to be open to other countries. In March 2021, both nations agreed to cooperate. And later that year, during a major space conference in St. Petersburg. Their space agencies presented the project's roadmap and a partnership guide. They then submitted these documents to the United Nations Committee on the Peaceful Uses of Outer Space. According to the plan, the research station was originally expected to be built between 2030 and 2035 through 5 missions carried out by both countries. However, Russia's invasion of Ukraine in February 2022 caused serious delays and complications for the project, affecting both its international support and its development timeline. At the same time, the United States is also moving forward with its own plans for the moon. After the Apollo program ended in 1972, the U.S. shifted its focus to low Earth orbit, developing the Space Shuttle and later the International Space Station. In 2017, it launched the Artemis program, which aims to send astronauts, both men and women, back to the moon. The program's first mission, Artemis 1, took place in November 2022. It didn't carry a crew, but successfully tested the new Space Launch System rocket and the Orion spacecraft. The second mission is intended to fly astronauts around the moon. By returning to the moon and planning for a long-term presence there, the United States hopes to reinforce its leadership in space exploration, something it increasingly sees as a direct competition with China. Even with America aiming high, it's hard to ignore how realistic and well-organized China's path to the moon has become. China has spent decades building up its space program, giving it not only the technical expertise, but also something many other nations lack, a consistent long-term vision backed by substantial funding. In 2024, China invested about $19 billion in its government space program. That's far below the US total, which was roughly $60 billion higher. But China's projects tend to face fewer political delays and are guided by stable multi-year planning. All of this has led many observers to note that a new kind of moon race is emerging. China and the United States are both investing heavily in lunar exploration, each hoping to build a human-crewed scientific station on the moon. But this race is different from the one in the 1960s. It's no longer just about planting a flag and coming home. This time the goal is to establish a lasting presence on the moon and use it as a stepping stone for deeper exploration of the solar system.